Hi everyone, welcome back to Tech-Bimba channel. In the last video, I had talked about introduction to transformer. In the today's video, we will further dive into transformer and we'll look into the new concept tokenization. Google Translate are the systems, they are responsible for translating the sentences from one language to another language. In this example, we can see that we have given the English sentence, how are you? And we wanted to translate into the Hindi and we got the output as aap kaise hai. This Google Translate uses the transformer. Let's try to understand how Google Translate uses this transformer to translate the sentences from one language to another language. Once the user provides the input, these words will be converted into the numbers. This is what we call it as a tokenization. Tokenization is the process of converting the text into a tokens. So once the user provides the text something like this one, this will be broken down into the words. Like hello is a one word, even comma, how are you, and even a question mark. Then for these each word numbers will be assigned. This is what we call it as a tokenization. Tokenization is required because systems, models, or even computers are very good at math and they are perform more better with the numbers than with the text. Because of that, this tokenization is very important step. Once the tokenization is done, encoder transformer is the one that is going to read this input and it is used to create the context out of it. So this creation of the context is nothing but it is used to understand that what all the user wanted to say, and after that one it is basically created the context, means kind of a representation. So decoder transformer is the one that will understand this context and it will start generating the tokens in the targeted language. In our case, Hindi is our targeted language. So decoder generated the tokens for the Hindi language for the corresponding words. So we can see that we got the numbers like 501, 603 and 702. But these numbers are not understood by the users. Because of that, one more step has to happen here. That what we call it as a detokenization. Detokenization is the process of converting the numbers back to the text, is what we call as a detokenization. Once the detokenization is happened, we finally got the output as a aap kaise hai. This is how Google Translate used to use the transformers for translating the sentences from one language to another language. So OpenAI has provided a one platform just to see how the tokenization works. So if I provide the sentence something like hi, how are you, and on click of the token IDs, this is the output we are going to see. So here we can see that hi is assigned to the one number that is 3686 and how is assigned to 1495 and r is assigned to 553 and u is assigned to 337. So this is how the tokenization used to work, and here we can see that we have assigned the models here. So in case I have assigned this model and we are going to get altogether different numbers here. This is how the tokenization is being used even in the LLM. Now let's try to understand how transformers are being used in the LLMs or GPTs. In case of a GPT, transformers are being used in a slightly different way. So the core fundamental idea of the transformer usage in the GPT is just to predict the next token. Once the user is provided the input, this input will go to first tokenization, means these inputs will be converted into a number. This text input will be converted into a number. So we can see that for the word hey, one number is assigned, and for the word there, one number is assigned. Okay, so this is the input to the transformer. So this is converted into a number. So 15496 and 612 are the inputs to the input transformer. Okay, what transformer will do is it will just predict the next word. So in this case, it predicted the next word as a I. And output at the end of the first iteration is I. This predicted output will be appended to the input. So in the second iteration, input to the transformer will become hey there I, and it predicted the output as a I am. So output so far is I am at the second iteration. In the third iteration, this I am got appended to the input again. So it will become hey there I am. The third iteration, it predicted the output as a good. So till now output is I am good. In the fourth iteration, this good appended back to the input again. So hey there I am good will be the input to the transformer. It predicted the output token as a dot. So till now our output will become I am good dot. At the fifth iteration, even this dot will appended to the input and it will be sent to the transformer. So in the fifth iteration, it received the or it predicted the output as a n, which means there are no further predictions. At this stage, this appending of the predicted output token in the next iteration will end and to the user output token will be provided. This is how the transformers are being used in the LLM to predict the next token. If you notice here, at every stage, token is predicted and it is being appended as a input. It is being appended to the original input and again sent to the transformer as an input. This process will continue until we receive the end. Even for the just a hey there are a 5 iteration. Because of that only LLMs are very costlier in operation and they require a GPUs, very high computational GPUs. Hope this is clear how transformers are being used to predict the next output token in case of a LLM. In the next video, we will further deep dive into transformer. If you found this video is helpful, please like and share to the friends. Thanks for watching.